AI, and she was associate professor at Paris Sud University, where she investigated local knowledge representation and symbolic machine learning. And in 2018, she co-founded Nook AI, where as a head of research, she led the research field on hybrid AI. So Nook AI is committed to creating new generation AIs at the service of humans instead of replacing them, and uses as sandbox the game of Bridge, which has resisted AI so far, unlike chess of Go or Go. In 2020, Forbes ranked Veronique Ventos third woman defining the 21st century AI movement. And in 2022, her team achieved a major scientific breakthrough when Nook, the hybrid explainable AI, beat 8 world champions at the Bridge Challenge that took place in Paris. I guess many of you already heard about this. So it's my pleasure, and I thank you very much, Veronique, for accepting our invitation. And I guess that's all I have to say. So I pass it over Veronique, and I will stop sharing screen now. Veronique, are you there?
Yes, but it says that I cannot start because somebody else make a partage.
Yes, so I stopped sharing screen. Now you can share.
Okay.
Should be able to share screen now.
Okay, perfect.
Yes.
Oh, I will remove that. Okay. It's okay. You see the screen?
Yes.
Okay.
Thank you.
So, hi everybody, and thank you very much for the invitation. As Vincent told you, I am a researcher in what we call symbolic AI. And since 4 years, I am the head of research at Nook AI, which is a special startup, a kind of private AI lab. And I co-founded this startup with Jean-Baptiste Quentin. And 3 months ago, Nook or Bridgebot won a challenge against 8 Bridge champions. So I will try to tell you a little more, but be indulgent because it's the first time that I present this part of our work, and my English is not so good. So in this talk, I will begin with a part on an overview over Nook AI. I will give some basic notion of the game of Bridge, and then present the challenge. Then I will go further into the research part of the related to Nooks, and finally I will conclude with the presentation of our explainable module, where we could see on the board what's on the Nook's mind. So, oh, sorry. Nook AI has a very modest goal, which is to create and design a new generation AI. And more seriously, the AI that we build are different from the classical one on 4 main points. The more important is maybe the fact that we want to keep a human in the loop. So we are building AI that allow a collaboration between human and machine. The second point is the fact that we want to have a white box and not black box. So we associate to every decision of the machine some kind of explainability. Our AI is also hybrid. I will instance this point on Nook after, but the principle is to combine different paradigms of AI and sometimes to create new one. And finally, we wanted our AI to be energy saving. So I begin with our sandbox. If you want to build something like next generation AI, we need something to make a progress on that. And we choose the Bridge as a sandbox. The first reason maybe is the fact that Jean-Baptiste and I are Bridge players. We meet together at a table of Bridge, but the sandbox of the game of Bridge is really related to the fact that it is a great challenge, and it still resists to classical AI. So it is the perfect game to develop new methods where there is a need of an hybrid AI system. Moreover, since the Bridge is a game and it's a challenge, if you want to build a hybrid AI, you should put together researchers from different domains, and it's very hard. At the university, people from different domains don't work together because they are not in the same conferences. They cannot understand each other because even if they handle the same problems, sometimes that they don't use the same word, etc. So the fact to have this huge challenge allows to gather a very hybrid research team. Here is the pictures of this team. So Nukai is young. It's only 4 years, but we are already 20. It's really an international dream team with people who are not interested by money, but by this challenge, and we work together. We have people from computer game like Tristan Cazenave, from inductive logic programming like Céline Overol, Dominique Boutinon, Henri Soldano, and also some postdoc working on time series or reinforcement learning, planning, etc. So here is our team, and the success in Bridge is not those of Jean-Baptiste and I, but it's really according to this dream team. And moreover, we have some collaboration with high-level researchers like Marie-Christine Rousset, which is professor at University of Grenoble, and she works on linked data, and this field is very useful for explainable AI. Then the goal is to build such a next generation AI. So I speak about hybridization, but the solution should be also adaptable. In fact, we want to provide the most efficient solutions, but we also want to provide explanations in natural language, and an explanation should be adapted to a user. You cannot have the same explanation, for instance, to a beginner, an expert, etc. So in fact, we can see Nook or next generation AI like an interactive AI toolbox that can be customized to resolve not any problem, but some problems. And what kind of problem? I think that our added value is related to complex problem. If you want to handle some pictures or video, it is not we are not relevant for this task, but every domain where there is a kind of semantics and issues with combinatorial complexity is very related to our approaches. And I won't give more explanations, but I will explain what we have done on the Bridge, but Nukai actually applies this method to a number of applications like education, cybersecurity, aeronautics, finance, etc. And in the same way, we aggregate different AI modules to specifically map the customer's ability to address these issues. So now let's come back to the main the bridge. So bridge has very simple rules. It's a trick card game, but with two steps. So the first step is called the bidding step, and the goal is to define a contract, the number of tricks, and also the trump or no trump. And in order to achieve this task, each player have some special bidding cards that allow us to establish a codified dialogue to describe the shape, the strengths of their hand. Because as you can see on the picture, Bridge is an incomplete game. During the first step, each player sees only his 13 cards. It is called his hands. And so during this communication, he can pass to his partner some information like, I have at least 5 cards in spade. I have between 12 and 15 points, with the ace is 4, queen 2, jack 1, and the king is 3. So, but what is very important is the fact that it is not a private code. It's a public code. So you pass information, but at each point, the opponents can ask you what is the meaning of the bidding sequence or of this special bidding card. And then there is really a need of explainability. You cannot have a bot that play and explain nothing, because the human cannot play without explanations. So this first step is not related to the challenge. I will explain it after. Since the challenge were related to the second step, which is called card game. And in special in this second step, the declarer will try to win the contract. So to do to make at least the number of tricks promises. And then his partner, called the dummy, put his 13 cards on the table. So the declarer will play in clockwise play with his cards and the cards of his partner, and the cards of this partner are seen by also the opponents. So then during this very interesting part of the game, both the declarer and the two defenders will set up their strategy using various information sources. So the rules are simple, but it's really a very difficult game. It is called the King of Mind Sports, and it is difficult both for human and for robots. Well, so I will explain maybe something about the challenge. So on March 24 and March 25, we receive 8 very high-level champions, 8 world champion bridge, and then during these 2 days they fight against Nook or bots. And as I told before, it was very important because we think that mastering bridge is a significant step towards artificial general intelligence. Bridge is incomplete information, but you have a partner and opponents. So it's a collaborative and adversarial. You should provide explanations. And in fact, to be more precise, to be champions or an expert at Bridge requires more the skills of a doctor than those of a mathematician, because in Bridge, since you don't have the complete information, you must be able to make some inferences related to what you have seen, what you don't have seen, and to make a different kind of reasoning. It is not just a computation of probabilities. And the goal is to use these inferences to reduce the level of incompleteness, and then you can play at best. So the challenge was related to the card play. And in fact, it was related to the card play of the declarer. So it is the player, we should win the contract. And Nook was a declarer. And each human champion was also the declarer with exactly the same cards. So Nook has the same card, the opponents have the same cards. And we were very, we make a lot of stuff to make this challenge fair for human. And it is the reason why we play the same contract. It's called Trino Tramp. For bridge player, it's a very famous contract. So you have no trump, you must make at least 9 tricks. And we provide the same deterministic defender. So it cannot be human opponents, because we cannot guarantee that it will be fair. And the 2 defenders were the 2 boats, W Bridge 5, which are the boats, the champion of world champion of bridge, that just boats against boats. And W Bridge 5 has been designed by your friend Yves Costel. And so they play against the human and against Nook. And what is very important also for the fairness is the fact that there was also the same lead. The lead is the first play card by the defense. And I think that the boats like W Bridge 5 could make some very special lead, and that if it was the case, the human will be disadvantaged. So each board was played 2 times, one by Nook and one by a human champion, like our friends, which is Brad Moss. And after that, we compare the results. So it is really what we call the duplicate scoring. And each champion played 100 boards. So Nook played 800 boards. And this is the results that we compare. So yes, as you know, the winner was Nook. Nook win against 8 champions. And besides, he was better than humans in 90% of the votes. And as you can see, it is the picture of the results. And of course, you can see our team, but also the bridge players. And it was really fantastic, since obviously bridge players were disappointed because they think that they will win against the boat, because they always win against the boat till now. But they were also very happy because they understood that some things happen. And then, in fact, their beautiful game was very useful to design and to create a new method for artificial intelligence, and that this method will be transferred to real life applications. So it was not as sad as when AlphaGo beat Lisedol. I don't know if you have seen it was a great result, but Lisedol was very disappointed, and then I think that he stopped the go. It is really not the case for bridge player. And besides, bridge players are still better than boat and some other part of the bridge. As I told you, it is only the card play on a contract. So now I should go into details on the research side. And here is just a schema of Nook. So as you can see, we have different modules. The first one related to the human expertise is a symbolic modules with a set of rules expressed in logic, high-level logic. It's a restriction of first-order logic. So we can represent the game rules, some rules related, for instance, to the lead. There is also a central module, which is a probabilistic heuristic search algorithm, and also a deep neural network that we have used to mimic the opponent strategy, so the mimicking W Bridge 5. And as you can see, the output of Nook is a decision, just a card to play, but each decision can be associated to explanation, since we want to make explainable or white box AI. So I will go also into details to maybe explain what can be a new generation AI. And the illustration of Nook can be done on different aspects. The first one is what we call a hybrid artificial intelligence. As I told you, hybrid artificial intelligence consists of combining approaches from different fields, different subdomains, and to combine them, but also when there is a need, it was the case for the bridge, to create new ones. And why Nook can be called a hybrid AI, as you have seen on the schema, Nook is a hybrid AI because it is made up of symbolic rule-based modules, also probabilistic, tree search algorithm, a neural network. And the part of the symbolic rule-based modules was very useful, since rather than learning by playing a huge number of boards, Nook begins by modeling and recovering human expertise in the background knowledge described in logic. And it is really what a human does, a child, when he begins to learn again. Some people give you some ideas of the rule games, etc. So what was very important, so the fact that Nook reproduces the human behavior. When we interviewed the champions during the challenge, they said that they told us that it was the first time that they play against a bot that play really like a human. And it is the reason why Nook begins to learn. It does not learn from scratch, since it begins to to handle the rules. And then we can say that Nook is both very efficient since it wins, but also close to human behavior, and it was very important. And why is the main difference between Nook and the previous boat of Bridge? In fact, the main thing is that if you want to reach the top level at Bridge, you should be able to put yourself in the place of the opponent. And the opponent doesn't have all the information. And it is the reason why the central module of Nook is innovative, because it is an anytime heuristic search algorithm, but that assumes imperfect information for the opponents, while the previous algorithms were assuming perfect informations. They use what we call double dummy solver. It's a solver when you know everything. And thanks to this new approach, Nook is able to make some psychological blows by imagining mistakes in the opponent rather than assuming that they know everything. It's really very, very important. And finally, what is noteworthy is that Nook is able to provide explanations related to each decisions. We do not use classical black box approaches. The main goal is to keep human in the loop. And if you want to keep, for instance, expert of Bridge in the loop, you should provide what they want as explanations. So we created an explainability module called What's on Nook's Mind. And this module allows us to show at any time during the board, according to a decisions, what the high-level vision of the informations of the hidden cards of the opponents of our robot is. And I think that it's really a good explanation for a Bridge player, since one day after competition, when they talk together, they ask, yes, why do you play like that? You can win, but it is not because you win something on one board that you have we can say that you have well played. But if you say, yes, I play like that because I know this thing, because this thing, because this thing, and if it is the good explanation, say, okay, well done. So I will also, just before explaining showing the explainability module, I will talk about the Nook central modules. This module is based on a variant of the alpha mu search algorithm, which is the baby of Tristan Cazenave. He worked at Nook with the team since 4 years, and I work with him on different aspects also, but a part of the team also. And so if you are interested in the original alpha mu, not those used for the challenge, it has been published in 2 conferences. And alpha mu is an anytime heuristic search algorithm for incomplete information games that assumes perfect information for the opponent, like the previous one. So it was better because better than the previous bots, but still far from the best human player. And I have explained before, if you want to reach the top level, you have to put yourself in the place of the opponent. So the variant of alpha mu that Nook used for the challenge make this choice, and he will make inferences through the deal to reduce the incompleteness in the hand of the opponents. And finally, Nook with this variant is much more efficient than our first boat, And it is this version that finally made it possible to master the best human players. Oh, so if you want to make inferences, you must have an idea of the strategy of the opponents. The human players have a lot of model of the opponent, even for the Bridge 5, because it is a classical boat. So the champions can train by playing against Bridge 5 before the challenge. And it is really, there is a website and an app. So it is a classical boat. And for Nook, as I told you, it use both the models in the form of rules and constraints, but also we have trained a deep neural network to mimic Bridge 5, and the training of this neural network relies on game where Bridge 5 has played against itself. It's a small network based on a ResNet 10. And we use only, we train the network on 10,000 boards. It's not a lot. And I forget this point, but Nook is also energy saving. We use 200,000 times less resources than those used for the Go challenge. And it is, the reason is that in fact the background knowledge, the symbolic approach allow us to really train on a very, very less example. So well, now I will explain maybe an idea of how the interactions are made in Nook. So the first thing is the fact that Nook interacts with modules that automatically generate constraints related to the opponent's strategy, of course, but also to the bidding. So the bidding is translated in some constraints, and the human player does exactly the same thing. And every constraint can be linked to the actions of the opponent. For instance, the lead card. The lead card provides a set of constraints since the card has been chosen according to a set of leading rules. But more interestingly, you should also obtain some constraint by the non-actions of the opponent. For instance, he did not play the ace of spade, so it doesn't have it. And from a technical point of view, since Nook uses Monte Carlo simulations, this set of constraints allows us to obtain samples of possible worlds that are really more relevant. And I think that it is the reason why Nook was so efficient. But it is really the same way of thinking that human have a lot of constraints, but they build an abstraction of the possible world, and the search space is really too high. At the beginning of the board, you have 5 billion possibilities, so human reduce the world. The number of words according to a lot of different kind of reasonings, and it is what Nook did also. So now the last part. Sorry, because I think that in fact this last part will be more useful for a bridge player. I will try to explain things related to that. For sure, when we show this to the champions, to bridge experts, they say, "Oh yes, it's really great and it is a good explanations." But it's really very, very bridge bridge problem. So I will try to explain that. As I told before, really the challenge was related to a new method, which is a major breakthrough. And so the incomplete information games, the fact that you and your opponents do not have access to the whole informations is really a good reason to to build the hybrid modules allowing to make inferences. So in these explainable modules, I will try to explain how these inferences against players without perfect informations has been built throughout the deal. And what is, in fact, at some point, the high-level probabilistic vision of Nook. It's very important here again, but I know that explainable AI is hype at the moment. It was not the case 4 years ago, but it's very important to choose the level of explainability. If you explain just at low level things, I think that human won't be very convinced by the explanations. So here I will show some abstractions of the vision that are very useful for bridge player, maybe not for you. Once again, sorry. I will illustrate the explainable module on a real board that has been by Nook and also by 2 champions. Here again, it's the same contract. The declarer should make at least 9 tricks at no trend. You can see here your cards, so your hand, and the cards of your partner, the dummy. And here is the lead, the first card played by West. West is the opponent at your left, and at your right, it is called the East partner. It's, sorry. So a bridge player, when he saw the 4 of Earth, he can make a lot of inferences because you know that the rule system is the force base. So he knows that how many cards the opponent has in this suit. He knows maybe that he doesn't have ace and king of spades because he would have lead spade, etc., etc. And after this card, so the Nook should play the dummy, and then the Est will play, and finally will play that. And so the first trick was like that. The 4, the 6 in the dummy is to play the jack, and you win the trick with the king. So the ace is the stronger, then king, then the queen, then the jack. And after that, during the second trick, the third trick, and the 4th tricks, it's exactly the same way of playing. Nook play likes the 2 champions. They play spade. I come back here, since he can make a lot of tricks in spade. In fact, 5 tricks. But in the 5th trick, the 2 champions go on playing spade, and Nook plays a very special cards, the 2 of club and the 3 of club in his hand. And so the opponents made 1 trick, and the 2 champions say that, wow, it's a very, very stupid cards to play. So can you explain us why did Nook play like that? Because we don't understand. So we used our probabilistic explainable module. And in fact, I will try to explain what's happened. So at the beginning, without any inference, the vision of Nook of any declarer is this one. West as it's only the cards, the SIM cards. So we have 4 tricks. So Nook and the champion see that just so that this card has been played. But here is the output of our explainable modules. So you can see the cards that have been played, but also some probabilistic abstraction visions. For instance, on the card, Nook knows that East is likely to have the 9 of club in 76%, but also some abstract vision. He has 2 cards in spade and 5 cards in diamond in 74% of case. And finally, sorry, a very important thing for if you want to play at top level is to have an idea of the distribution. The distribution is the number of cards by suit. For instance, here, Nook knows that in 72% of the case, East has 2 spade, 3 heart, 5 diamond, and 3 club. And for bridge player, it's very, very important. So what can it do with this kind of informations? The inferences are linked to the lead rule inferences. So he knows that West has 4 hearts. He doesn't know which one, but 4 hearts. And so East has 3 hearts, since you have 5 hearts, and there are 13 cards by suit. And after the 3 tricks of spades, he plays spade, spade, spade. In fact, we have seen that he knows that East has 5 diamond and 3 clubs in 72% and 4 hearts. But the conclusion for Nook is the fact that East has always more club than West. So, sorry. So after that, he decided to play the very special move, the 2 of clubs. And according to this play, he knows that, but it's really an advanced inferences. He knows that the king of club is at 100% in its end. And it is not a card that has been played. So can explain the reasoning, but sorry, I think that it is very bridge. But in fact, as you see before, he knows that East has always more club than West. He knows that East has 3 or 4 club. But when he played the 2, here is West. West cannot have, in fact, the king, because when you play the 2, you see that West played the 8, and for a lot of reasons, with Jack 10-8, West would have played the 10 or the Jack. It is a classical strategy of the opponent of the defense. So he has 3 clubs, and with Jack 10-8, he would have played not the 8, but the 10 or the Jack. So he has for sure the king of club. And after that, when it generates in his sample the king of club, he decides to play diamonds in order to end play east. So it's also a special strategy where you can sometimes choose which opponent will win the trick, and then you know that since the player who win the trick will play the first card of the following trick, he choose to end play east because east will give him the over trick, and finally Nook win this board. It was very spectacular, and both two champions didn't win this board. And before we show to them the vision of Nook, they say, "Oh, it's a very stupid way of playing." And after they say, "Yes, it's really, really very, very well done." And if we have maybe more time, maybe we should have found this solution. So, really, once again, sorry, because it's really, I think, a lot of things about Bridge. But to conclude, I would say that, of course, this victory is a world premiere, and we were very, very happy. But it is just a small part of the bridge, and there are still many, many bridge challenges. I think we think that Bridge is so difficult that we can use it to develop again and again new methods. And concerning the future works at Nukai on this part, because we have a lot of future works on application, etc., but it is not the point here. The first one is the fact that we will work on the defense. So this time you have a partner, and the card play in defense is very, very interesting from a research point of view, since the goal is not only to win tricks, but also to help your partners. So since your partners doesn't know what you have in your hand, sometimes you can have a very efficient card to win a trick, but you know that your partner will miss something and that he will make a mistake, etc. And it's very interesting because there is a kind of epistemic reasoning. I know that my partner knows that I don't know that, and that the declarer knows that I don't know, etc. So we work on this point. And finally, I think that it will be very interesting to find some new Monte Carlo search algorithms like AlphaNu, but AlphaNu for the defense. And I will finish with my favorite project. This project is related to a new kind of bridge player. It's not a human against machine, but a human machine player. So for instance, as a declarer, you play with the Nook and a good interface, of course. And it could be the machine or you that choose the card. So it will be very interesting because you will play against Nook with another human. And in fact, I think that it's not only interesting for Bridge, because in most of the case for applications, you should choose between human or machine. Oh yes, I try to make a planning task, and the planner is not good, so I stop and the human make everything. I think that the future of AI is also a hybrid AI where the human and the machine could collaborate. And if you want to collaborate, you should have a good interface. You should have explainability, of course, and it is not only the human that use the machine, but what is very interesting from a research point of view is to develop algorithm and method where the machine knows that she can use the human expert to be better. Well, thank you for your attention. And
Thanks,
Thanks.
Veronique. Very nice talk. Thank you very much. We are all clapping, although we cannot hear the claps. So we have a time for some questions and discussion.